Imagine looking into the night sky and realizing that everything you see, every star, every galaxy, every glowing cluster of billions of suns, is racing away from you. Not just drifting, but accelerating, like cars on a cosmic highway pushing harder on the gas pedal the farther they go. This is not science fiction. It is one of the greatest discoveries in modern science. The universe is not only expanding, it is expanding faster and faster. And the invisible force behind this acceleration has been given a name as mysterious as the phenomenon itself: dark energy. Today, dark energy represents one of the deepest unsolved riddles in physics. It makes up about 70% of the cosmos, yet we have no idea what it truly is. It is everywhere and nowhere, invisible yet dominant, silent yet powerful enough to determine the fate of the universe. In this journey, we will unravel the story of how we discovered dark energy, what scientists believe it might be, and why understanding it could change everything we know about reality. For millennia, humanity assumed the universe was eternal and unchanging. Even Albert Einstein, when formulating his equations of general relativity in 1915, believed the cosmos must be static. His math, however, suggested otherwise. It predicted either an expanding or contracting universe. Einstein, unwilling to accept such a radical outcome, added a term he called the cosmological constant to counteract expansion and keep the universe balanced. But in 1929, astronomer Edwin Hubble changed everything. By observing galaxies with the 100-inch Hooker telescope at Mount Wilson Observatory, Hubble found that nearly all galaxies were moving away from us, and the farther away they were, the faster they receded. This became known as Hubble's law, and marked the first evidence that the universe was expanding. The static universe idea was dead, and Einstein would later call his cosmological constant the biggest blunder of my life. Little did he know, that same concept would return decades later as the leading explanation for dark energy. If the universe is expanding, then logic dictates that it was smaller in the past. Extrapolating backward, scientists realized the cosmos must have begun in a hot, dense state, a theory we now call the Big Bang. Measurements of the cosmic microwave background radiation, the faint afterglow left over from the Big Bang, confirmed this picture in 1965. The universe has been expanding for about 13.8 billion years, cooling and forming stars, galaxies, and planets along the way. For decades, cosmologists assumed this expansion would gradually slow down, like shrapnel from an explosion slowed by gravity. The big question was, would gravity eventually halt expansion and cause a big crunch? Or would the universe coast forever, slowing but never stopping? Few imagined a third possibility, that expansion might speed up. Yet that is precisely what we discovered at the turn of the 21st century. In 1998, two independent teams of astronomers, the Supernova Cosmology Project and the High-Z Supernova Search Team, made a stunning discovery. By studying type Ia supernovae, exploding stars that act as cosmic standard candles, they could measure distances to faraway galaxies with remarkable precision. What they found was shocking. Distant supernovae appeared dimmer than expected, which meant they were farther away than predicted. In other words, the universe's expansion was accelerating. Something unknown was pushing galaxies apart faster and faster. This was the birth of dark energy as a scientific concept. In 2011, the leaders of both teams, Saul Perlmutter, Brian Schmidt, and Adam Rees, were awarded the Nobel Prize in Physics for this discovery, which remains one of the most important breakthroughs in cosmology. So what exactly is dark energy? The honest answer is, we don't know. The term is essentially a placeholder, a label for our ignorance. We know it must exist, or at least something like it, because we observe its effects on the expansion of the universe. But its nature remains elusive. Dark energy is not the same as dark matter, which is invisible mass that holds galaxies together. Dark matter pulls, but dark energy pushes. The leading explanation is that dark energy could be the cosmological constant Einstein once proposed, the energy of empty space itself. In quantum field theory, even a vacuum is not truly empty, it teems with virtual particles popping in and out of existence. This so-called vacuum energy could generate a repulsive force that drives cosmic acceleration, but when physicists try to calculate this vacuum energy, the result is off by a factor of 10 circumflex 120, the worst mismatch between theory and observation in all of science. This colossal discrepancy is known as the cosmological constant problem, and it highlights how mysterious dark energy truly is. Because the cosmological constant explanation is so unsatisfying, physicists have proposed alternatives. One is called quintessence, a dynamic energy field that changes over time and space, unlike the constant energy of the vacuum. Quintessence could potentially explain why the acceleration of the universe began relatively recently on cosmic timescales, billions of years after the Big Bang. Another possibility is that general relativity itself may break down on large scales, meaning we might need a new theory of gravity to explain cosmic acceleration. There are also radical ideas suggesting that dark energy could be linked to extra dimensions or the multiverse. Each possibility carries profound implications for the nature of reality, and each remains unproven. How do we study something we cannot see, touch, or directly detect? Astronomers rely on indirect measurements. Type Ia supernovae remain a key tool, serving as cosmic yardsticks. Baryon acoustic oscillations, ripples in the distribution of galaxies left over from sound waves in the early universe, also provide a cosmic ruler to measure expansion. The cosmic microwave background, CMB, offers a snapshot of the universe when it was just 380,000 years old, and the tiny fluctuations in the CMB encode information about dark energy. In July 2023, the European Space Agency launched the Euclid mission, a space telescope designed specifically to map billions of galaxies and measure the geometry of the universe with unprecedented accuracy. By studying how galaxies cluster and how cosmic expansion has evolved, Euclid aims to reveal the nature of dark energy. Meanwhile, the James Webb Space Telescope, JWST, launched in 2021, is also contributing by observing extremely distant galaxies, helping scientists trace the universe's expansion back to its earliest epochs. One of the most unsettling results of modern cosmology is the cosmic inventory. According to the latest data from the Planck satellite and other missions, the universe consists of about 70% dark energy, 25% dark matter, and only 5% normal matter, the atoms that make up stars, planets, and people. That means everything we see, every galaxy, every mountain, every living thing, is just a tiny fraction of reality. The vast majority of the cosmos is invisible and mysterious. Dark matter holds galaxies together, dark energy pushes them apart, and we barely understand either one. Why does dark energy matter so much? Because it determines the fate of the universe. If dark energy is truly constant, then the cosmos will expand forever, with galaxies receding faster and faster until eventually even starlight cannot bridge the growing void. This outcome is known as the Big Freeze, where the universe becomes dark, cold, and lifeless over trillions of years. If dark energy grows stronger over time, it could lead to the Big Rip, in which galaxies, stars, planets, and even atoms themselves are torn apart by runaway expansion. Alternatively, if dark energy weakens or changes sign, gravity could one day halt expansion and reverse it, leading to a big crunch, where the universe collapses back into a fiery singularity. Which of these fates awaits us depends entirely on the true nature of dark energy, a mystery we have yet to solve. At first glance, dark energy may seem like an abstract concept far removed from human life, but in truth, it touches on the deepest questions of existence. It tells us that the universe is stranger than we ever imagined, dominated by forces we cannot see or fully explain. It reminds us that science is still young and that our greatest discoveries may still lie ahead. Dark energy also humbles us, showing that everything familiar, our sun, our earth, our lives, are just tiny sparks in a vast ocean of the unknown. To search for dark energy is to search for our place in the cosmos. The mystery of dark energy is not just scientific, it is existential. We live in a haunted universe, surrounded by an invisible presence that pushes galaxies apart and writes the ultimate ending of the cosmos. We cannot see it, cannot touch it, yet it makes up most of everything that exists. Perhaps dark energy will one day be explained by new physics, or perhaps it will always remain a cosmic enigma. But either way, it reminds us of the extraordinary power of human curiosity. Just a century ago, we didn't even know the universe was expanding. Now we know it is accelerating, driven by a force beyond our comprehension. Every discovery brings us closer to the truth, yet also reveals how much more there is to learn. To contemplate dark energy is to feel both fear and wonder, terror and awe, at the scale of the cosmos and the fragility of our place within it. So what is dark energy, and why does it make the universe expand? We don't yet know, but we are closer than ever to finding out. With missions like Euclid, James Webb, and future observatories, humanity is on the brink of unlocking one of the greatest secrets of existence. Thank you for joining me on this journey into the heart of the unknown. If this video inspired you to look at the universe differently, please tap the like button, subscribe to Beyond X, and hit the notification bell so you never miss another exploration into the mysteries of space. Together we will keep asking the big questions, chasing the great mysteries, and reaching for the answers written in the stars.